All right, at this point in our class, we learn about a new type of differential equation. And if you think about what we've been through to get to this point, and to solve a differential equation, you first classify it as being a certain type of problem, and it lends itself to a certain type of solution. Well, it's the same thing here, all right? The jargon, we call this right here a second order. It's second order because the highest derivative for our supposed functional answer y is y double prime, so that makes it second order. It's an ordinary differential equation. Everything we do in this class is an ordinary differential equation because there's no partial derivatives. Okay, and this one has constant coefficients a and b, okay? What if there was a coefficient on y double prime? We could just divide it out into this form, so that's the way that we'll write it. If you have something like that equal to 0, we call it homogeneous, okay? All right, so let's take this one that you're looking at right there. It was obviously like this with no constant right there, and it's homogeneous and so on. So that's what we're talking about. And I wanted to, before I tell you how to do this, see what you think the answer is going to be. Some function of t, it's like every differential equation has some function to be its answer. So just what do you think? Like, what would be such that if you had this function, y is a function t, and you found the second derivative and you subtract the first derivative, you got 0. I can think of one real obvious answer, and I'll make a list of things that I think could work. So first thing, what if y was just a constant? That would work. What's the first derivative? 0. And what's the second derivative? Also 0. So it looks like any constant function would do that. The second minus the first derivative is definitely going to be 0, no matter what that constant is. So here's one of them. What else? Just try and think of something else that would do that. Something I could think of is y is equal to e to the t. What's my reason? So y prime is e to the t power, but so is y double prime. So take that as your answer. Y is equal to e to the t power. Is it true? Y double prime minus y prime is 0 is definitely true. Let's do one more, just for dramatic effect. Say y is equal to 4 times e to the t. Would things be any different here versus there? Not really. Y prime is 4 e to the t, and so is y double prime. So they're the same. So when you subtract them, you still get 0. All right. So it seems like there could be lots of answers to this. I could keep going with variations on this one. So here's what we can do. All right. The general solution is a linear combination of linearly independent particular solutions, all right? And all that would mean for us is that the most general form of the solution to that, the form that all answers to this must take, is going to be some arbitrary constant times that. So I'll say c1 times e to the t plus there's this, and that's really the same form as this one. So it appears in our general solution that way. Plus, what was the other kind of answer to this? Is that one. So we say plus C2. Okay. So there's your general solution. So if you could somehow find answers to that were linearly independent, meaning that this one is not just a multiple of that one or vice versa, then combine them like so, you'll get your general solution.